This video is presented to you by www.testprepadda.com. Dear students, in this video lecture of General Organic Chemistry, I am going to talk about another intermediate, that is free radical, carbon free radical, or I say alkyl free radical. You can see here a free radical contains an unpaired electron on carbon atom. Free radicals are neutral and paramagnetic due to presence of unpaired electron. For example, if I write this is methyl free radical, I can write CH2 double bond CH single bond CH2 free radical. This is allyl free radical. This is allyl free radical. This is methyl free radical. If I write, I can write this as benzyl free radical. This is benzyl free radical. Everywhere you can see this carbon has got unpaired of electron, and because of that it is paramagnetic in nature. Alkyl radical is tri-coordinated carbon. You can see everywhere this carbon here attached with the 2 hydrogen and 1 carbon, here 2 hydrogen, 1 carbon, here 3 hydrogen atoms. So it is trivalent, you can say, bonded to alkyl groups or hydrogen atoms. That says alkyl free radicals can be classified as primary, secondary and tertiary depending upon carbon atom having unpaired electron is bonded to 1, 2 or 3 other carbon atoms. For example, if I write CH3 CH2 free radical, here you can see this carbon which has odd electron is attached with one other carbon atom. That is why this is primary alkyl free radical. Now second, CH3 CH CH3. Now here you see this carbon which has odd electron is attached with two other carbon atoms. That is why it is secondary. Now CH3 free radical here, CH3 CH3. Here you can see this carbon is attached with three other carbon atoms. That is why it is tertiary. This is tertiary free radical. My point is clear. Now I will talk about the structure of free radical. If I take methyl free radical, this is CH3 having odd electron. Here, if I ask you the hybridization of this carbon, for that you will say that carbon has got 4 valence electrons. Out of 4 valence electrons, it forms 3 sigma bonds with hydrogen, 3 sigma bond, and remaining is actually 1 electron, 1 odd electron you say. So here it is difficult to find the hybridization because of the presence of odd electron. Now if I tell you the shape of this methyl free radical, this is triangular planar. This indicates if I draw this structure, it will look like this: hydrogen bonded here, hydrogen here, hydrogen here, and one perpendicular orbital to this plane which has this odd electron. On the basis of this triangular planar shape, we can easily say that here the hybridized carbon is actually sp2. So sp2 hybridized orbital will accommodate this odd electron here. Now if I take the example of tertiary butyl free radical, here the shape is not exactly planar. It deviates from planarity little bit, and it becomes a bit pyramidal. Not exactly, it is still towards planarity, but planarity is lost here. And if I replace CH3 with F, here the shape is found to be pyramidal. Here flattened pyramidal, you can say. Here it is pyramidal. Pyramidal, you can draw like this. In this case, what will you say? Because of pyramidal, the hybridization will be sp3. Means this odd electron will be present in what orbital? sp3 orbital. My point is clear? Now I will talk about the stability of free radicals. In general, if I write alkyl free radical, it will be this. So here the stability will be decided by the delocalization, of odd electron. More delocalization implies more stability. And it's very easy to find the stability of alkyl free radical. Two important factors that decide the stability of free radicals are mesomeric effect, or better I say resonance, and second is hyperconjugation. Condition for mesomeric effect is, or resonance is, this odd electron should be in conjugation with a double bond. Odd, single, double. For example, CH2 double bond CH, single bond CH2. For example, this benzyl free radical. Hyperconjugation. The condition for hyperconjugation is the carbon which has odd electron should be attached with alpha carbon having hydrogen. At least one alpha hydrogen should be there for the free radical to exhibit hyperconjugation. So two important factors responsible for the stability of free radicals. While for carbocations and carbanions, if I give you this chart, mesomeric effect, inductive effect, and hyperconjugation. Three main factors. If I talk about carbocations, you will see mesomeric effect, inductive effect, as well as hyperconjugation. If I talk about carbanion, you will check mesomeric effect, inductive effect, but not hyperconjugation. But if I talk about free radical, you will check mesomeric effect, hyperconjugation, and not the inductive effect. So for free radicals, the two special factors are mesomeric effect and hyperconjugation. If I take the example like this, this is allyl free radical, this is tertiary butyl free radical, this is isopropyl free radical, this is ethyl free radical, this is methyl free radical, this is vinyl free radical, and then phenyl free radical or aryl free radical. Now if you compare these free radicals, you will find odd electron single double, odd electron single double. So these two will exhibit resonance, while here you will check the hyperconjugation. Now resonance stabilized, that is why stability will be more than the others. But out of these two, if you write the resonating structures, here you will find two resonating structures, while here you will find five resonating structures. That is why this benzyl free radical is more stable than this allyl free radical. Now this allyl free radical will be more stable than this tertiary butyl free radical, although here 9 alpha hydrogen, 9 hyperconjugative structures where hydrogen participates in the hyperconjugation. But resonance gets preference, that is why this will be more stable. Here you can see 6 alpha hydrogen. Here you see 3 alpha hydrogen. So stability order will be like this. And vinyl and this phenyl free radical, these are very less stable, and that is why you can simply write this stability order. So to find the stability of free radical, we check first resonance and then we check hyperconjugation. Are you getting my point? This is all about the stability of free radicals. In the next video lecture, I will talk about two another intermediates, carbene and nitrene. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.